Hi everyone, I hope you're okay, and I hope that the videos we keep uploading are helping you out. On this video, guys, we will be tackling the 8th question from the May June Mathematics Paper 2 examination, which was written in the year 2024. Please note that, guys, the other questions are already uploaded, and each and every question have its own video. And please note that, guys, it's very important for you to know how to tackle exam questions. I truly believe it will give you an edge whenever you write your final exam. So please do share the video to your peers so that they may have the same edge as you. Okay, in the diagram, chords AB, BC, and AC are drawn. In the diagram, chords AB, BC, and AC are drawn in the circle with center O. DCE is a tangent to the circle at C. Okay. We are supposed to prove the theorem which states that the angle between the tangent to the circle and the chord drawn from the point of contact is equal to the angle in the alternate segment. Basically, they want us to prove it's an chord theorem, that the angle between the tangent and the chord is equal to the angle subtended by the same chord in the alternate segment. Are you together? Okay. Before we start proving, the first thing we need to do is to construct a diameter. Let me call it diameter PC, and also construct chord PB like this. Make sure that, guys, your diameter passes through the center, because if your diameter does not pass through the center, is not a diameter. That's simply a chord. So now I've constructed diameter PC and line PP. Are you together? And please let this angle over here be equal to C1 and that one be equal to C2. Okay, now let's write our proof. For our proof, I know that angle PBC is equal to 90 degrees. Angle PBC is equal to 90 degrees, and the reason behind that is that this is an angle in a semicircle. Are you together? Every angle which is subtended by a diameter, guys, at the circumference is always equal to 90 degrees. Okay, but then we also know that angle P plus angle C1 as well as angle PBC, they all sum up to 180. This is the sum of angles of triangle PBC. Are you together? We do not know the value of P and the value of C1 as well, but I know that this angle over there is 90 degrees. So I can therefore conclude that angle P is basically equal to 90 minus C1. Please keep this statement in mind. Okay, what else do we know? I know that PC is perpendicular to DE. The relationship between a tangent and the diameter, guys, they are always perpendicular. So I can therefore conclude that angle C1 plus angle C2, they both equal to 90 degrees, and hence angle C2 will be equal to 90 degrees minus angle C1. Please do check this as well. And then now I can simply conclude that it simply means that angle P is equal to angle C2. Why? Because both angles are equal to 90 degrees minus C1. Are we together? But what else do I know? I know that chord BC subtends angle A at the circumference. The same chord subtends angle P at the circumference. So I can therefore conclude that angle P is equal to angle A. These are angles in the same segment. These are angles in the same segment, right? So now I can conclude that angle C2 is equal to angle A. Why am I saying that? Because both angles are equal to angle P. Are you together? So now I can therefore conclude that BCE is equal to A. Why? Because BCE is the same as angle C2. Are you together? So I can simply write therefore angle BCE is equal to angle A. Now I have proven my tan chord theorem. Okay. 8.2, we are told that in the diagram PQRS is a cyclic quadrilateral with RQ equal to RS. And then we are told that ST is a tangent to the circle at S, and then SR is produced to N. Then we are told that R2 is 68 degrees. Once they start mentioning the term tangent, there are three theorems I need to think about. Now, firstly, the relationship between the tangent and the radius, or tangent and the diameter. Secondly, the theorem that simply says the angle between the tangent and the chord is equal to the angle subtended by the chord in the alternate segment. Are you together? The third theorem I need to think about is the one that has tangents from the same point. So over here I only have one tangent, so I will either focus on tan chord theorem or the theorem that talks about the relationship between the tangent and the diameter. Are you together? But over here they never said anything about the center. So the relationship between tangent and diameter, or tangent and radius, is out of the conversation. That means the only theorem we will focus on that has to do with tangents is only tan chord theorem. Okay, and I know that the angle between the tangent and the chord is simply equal to the angle subtended by the chord in the alternate segment. Okay, and then we were also told that we have a cyclic quad. If this is our cyclic quad, guys, I know that opposite angles of a cyclic quad firstly are supplementary, and secondly I know that an exterior angle of a cyclic quad will always be equal to the interior opposite angle. Are you together? So angle R2 will be equal to angle P. Okay, let's answer these questions. Firstly, they say to us, determine with reasons the size of angle P. I know that P is simply equal to angle R2, which is 68 degrees. Why? Because it's an exterior, R2 is an exterior angle of cyclic quad PQRS. Okay, now I know that's over here I have 68 degrees, and then they want us to find Q1. We were given that it was given to us that RQ is equal to RS. This was given to us. Are you together? I can therefore conclude that angle S2 is equal to angle Q1. Why? Because these are the base angles of an isosceles triangle. This triangle over there, guys, is isosceles. Why? Because the two opposite sides are equal. So we can simply say base angles of an isosceles triangle, or simply say equal sides of a triangle will always subtend equal angles. Okay, and then now what else do I know? I know that angle R2 is equal to angle S2 plus angle Q1. This is an exterior angle of triangle QRS. R2 is an exterior angle, guys, of the triangle, right? I know that R2 is 68 degrees, but both S2 and Q1 are equal according to that statement over there. I can simply write Q1 plus Q1. So 68 degrees is 2 times angle Q1. Therefore, Q1 is just 34 degrees. So angle Q1 is basically equal to 34 degrees, right? And then now they want us to find the size of angle S1. I know that angle S1 is equal to angle Q1. That means S1 is also 34 degrees. This is true because of a tan chord theorem. Tan chord theorem. That's how, guys, we're supposed to tackle this question over there. So just stay tuned and wait for more videos. Thank you.